Let's look at a question asked from the topic of structures in the GATE Aerospace 2022 paper. A cantilever PQ of rectangular cross section is subjected to a transverse load F at its midpoint. Two cases are considered as shown in the figure. In case 1, the end Q is free, and in the case 2, Q is simply supported. We are asked to calculate the ratio of the magnitude of the maximum bending stress at P in case 1 to that in case 2. From case 1, we can see the moment at point P1 is equal to F times L. And from case 2, we can see the moment at P2 is equal to F times L minus Fq times 2L. Fq is a reaction at Q. We will first need to calculate the value of Fq, and this can be done using superposition principle. The second case can be equivalently showed as a cantilever with a force acting at the center and a cantilever with a reaction force acting at the far end. The deflection in the first case is given as delta Q1, which is 5 by 6 FL cube divided by EI, and this is downward. And the second case, the deflection in the far end side is going to be delta Q2, which is equal to R at Q times 2L to the power of 3 divided by 3EI. But the net deflection has to be equal to 0. So delta Q1 should be equal to delta Q2. The deflection in delta Q2 is upwards. So on equating these two equations, we get RQ is equal to 5 by 16F. Here, RQ is also FQ. We can now find out what is the maximum bending stress in the case 1 and the maximum bending stress in case 2 and take its ratio. And this will be equal to M at P1 and M at P2. Substituting the value of RQ or FQ, we'll get FL divided by FL minus 5 by 16 F times 2L. And the ratio is approximately 2.667. But in our question, they've asked us to round it off to one decimal place, so we get 2.7.